Alice, Bob, and Eve explain quantum advantage.
I've been working on this maze for 20 minutes now. There must be a faster way to find the exit.
You know, your maze-solving challenge reminds me of quantum advantage in computing.
Quantum advantage is such an important concept. It's when quantum computers can solve certain problems substantially faster than classical computers.
How does that relate to my maze?
Imagine if instead of tracing one path at a time through your maze, you could somehow explore all possible paths simultaneously. That's similar to how quantum computers leverage superposition.
A classical computer, like you solving the maze now, has to check paths one by one. A quantum computer could, in theory, check many paths at once.
So quantum computers are just faster at everything?
Not at all. Quantum advantage only applies to specific types of problems. For many everyday tasks, classical computers work perfectly fine or even better.
Think of it like this. If I gave you a lock and a bundle of keys, and one of these keys opens it, a classical computer would try each key one by one.
And a quantum computer?
A quantum computer, through algorithms like Grover's search, could find the right key in roughly the square root of the time. So, if there are 100 keys, instead of potentially trying all 100, a quantum approach might find it in about 10 attempts.
For certain problems, the advantage is even more dramatic. Shor's algorithm can factor large numbers exponentially faster than the best-known classical algorithms.
Has quantum advantage been demonstrated in the real world?
Well, yes. In 2019, Google claimed quantum supremacy when their 53-qubit Sycamore processor performed a specific calculation in 200 seconds that they estimated would take the world's most powerful supercomputer 10,000 years.
Though IBM later suggested their supercomputer could actually do it in 2.5 days with the right approach, which still demonstrates quantum advantage, just not as dramatic.
So for some paths in the computing landscape, quantum computers offer significant shortcuts, but not for others?
Exactly. Areas like cryptography, optimization problems, quantum physics simulations, and certain types of search problems are where we expect to see the most significant advantages.
But for tasks like word processing, web browsing, or simple arithmetic, classical computers remain perfectly suitable.
So it's not about quantum computers replacing classical ones.
It's about having the right tool for specific jobs. The exciting part is discovering which problems have quantum advantage and developing algorithms that exploit it.
And just like you, eventually will found your way through the maze with persistence, researchers are navigating the complex landscape of quantum algorithms, finding paths to quantum advantage, one breakthrough at a time.
So the next time I'm solving a maze, I'll remember that there are some problems where taking all paths at once would be the ultimate shortcut.